Hi, my name is Akan. I'm here to talk about my um, project called Pulse, which is a submission for this hackathon in the infrastructure tract. Um, Multiverse X introduces a game changing architecture where we've got consensus and execution being decoupled. This is great for scalability, but over time it creates a critical challenge for high frequency autonomous agents. Essentially, we've got the execution gap problem. So, blocks are proposed by validators, but most times execution happens asynchronously with a delay. And during periods of high network activity, these gaps can grow to about 10 blocks, at least in DevNet. Um, Agents read these states, they see stale data, and they're operating essentially on blocks that haven't executed yet. And this tends to lead to failed transaction, wasted gas fees, missed opportunities, and certain undefined race conditions. So imagine if you got a trading bot that sees a profitable arbitrage opportunity, it reads the current state and then calculates the trade and then submits a transaction. But by the time the transaction executes, the state has already changed because the bot was reading from a proposed block that hasn't been executed yet. Um, so the solution is Pulse. Pulse is a latency aware orchestration layer that protects autonomous agents from network back pressure. So what Pulse does is it monitors the block gap, which is the difference between the proposed and executed blocks in real time. And this metric tells the agent if are you safe to execute and are you about to act on or are you about to act on a stale state. How this works is if you look at the repo structure, I've got the Pulse contract that deployed all on DevNet. It's got an Oracle and an execution contract there also, which I'll talk about later on. But there's a core engine that does lots of stuff. This core engine essentially um, is the one that's responsible for powering most of the. So it pulls this data directly from DevNet, and it's then runs it through a simplistic machine learning model that does certain predictive analysis to determine when to execute certain transactions for agents. It's all in the documentation. Um, I try to modularize them and not put everything in one main.rs file. So we've got um, an AI module that does the AI prediction, and I try to connect that to an LLM to try to give a simplistic explanation that can be understood by both humans and agents alike. So looking at the dashboard, we've got a simple network status here. This is currently monitoring on DevNet, and it tells us that at this point latency is low. Um, Probably the best time to execute whichever transaction or whichever orders your agent might have. But interestingly, I added like a chaos mode here. So I've just clicked it. If you try to activate it, what it does is it simulates like a very congested network, and then you see how the network reacts to this. See the block gap spikes, the velocity also increases. Now we've got block gap of about 14, which is a very, very congested network, and that updates also. And the AI here tries to explain in simple terms what this means. And if you disable it, it switches back to pulling data directly from from DevNet, and just telling you exactly what's going on. So essentially, probably best time to to execute any of those transactions from those agents you want to do. So, but the interesting thing about this is, I've fine tuned what's stable, unstable and unstable network statuses mean. So you can essentially configure certain cutoffs and certain threshold and be like, oh yeah, if it goes above this threshold, maybe just put out a warning flag there. I just went with certain not an arbitrary value, but I just picked what I considered from my little research during this hackathon would be like thresholds for like warning and like a clear stop. Also, it's got charts also. and it's also got like a place where you can add agents. So you can